Deep in space, giant clouds of hydrogen gas drift in complete silence. From the outside, a nebula looks peaceful. Inside that dust cloud, however, gravity is pulling every single molecule together. Trillions of tons of matter are being relentlessly dragged toward a dead center. As the gas crushes inward, the friction builds. The temperature hits 10 million degrees Celsius. At that exact threshold, the hydrogen atoms slam into each other and fuse. That glowing cosmic cloud is the ignition sequence of an inescapable cosmic bomb. We call this the main sequence phase. A star in this phase is a continuous, unyielding nuclear weapon detonating in real time. This animated diagram shows a star's cross-section. Outward-pointing arrows represent thermal energy pushing outward as millions of tons of hydrogen fuse every second. Inward-pointing arrows show the star's sheer mass pulling back. Gravity constantly tries compressing all that matter into nothingness. If you stood near this physical clash of forces, the resulting thermal shockwave would vaporize your atoms instantly. Every second a star shines, it is fighting a desperate war. Its entire existence is a temporary stalemate against infinite gravity. Eventually, the fuel runs out. The core burns through its last reserves of hydrogen, breaking that delicate balance. Without outward thermal pressure, gravity takes over. It crushes the core inward with horrifying force. As the core shrinks, the star's outer layers react in the opposite direction. The plasma swells into space, ballooning the star into a red supergiant. On a planet orbiting this dying star, the sky turns into a wall of boiling fire. Solid rock melts into liquid glass before vaporizing completely. Surviving the violent birth of a star guarantees you are directly in the path of its bloated, desperate death throes. Deep inside, the crushed core is panicking. To stay alive, it frantically fuses heavier elements, mashing helium into carbon and carbon into oxygen. This fusion chain reaction builds heavier elements, ultimately creating the deadliest substance a star can produce, iron. This diagram shows the physics of an iron core. Instead of releasing energy, iron acts like a sponge. It absorbs the star's thermal energy. The poison works fast. Fusion reactions fail. Outward thermal pressure dies, leaving gravity entirely unopposed. By frantically creating the heaviest elements to survive, the star engineers its own execution. Gravity finally wins. The moment the iron core solidifies, fusion stops. The interior goes perfectly silent. The star is left entirely defenseless against millions of miles of its own weight. The star's entire mass falls inward all at once. Trillions of tons plummet toward the center at a massive fraction of light speed. That falling matter hits the ultra-dense iron core and violently rebounds, reflecting outward into an explosion we call a supernova. This final act is a localized apocalypse, reaching temperatures high enough to synthesize the building blocks of planets, while simultaneously erasing everything in the solar system. When the shockwave clears, a cosmic corpse remains. For lower mass stars, you are left with a neutron star, an eerie sphere where a single teaspoon of matter weighs 1 billion tons. For the most massive stars, gravity creates a singularity, a point of infinite density, where the pull is so intense that not even light escapes. Pull back to our own solar system. While our sun is too small to create iron or explode as a supernova, it still faces the same core collapse crisis that forces its outer layers to expand. Every sunny afternoon is powered by a contained nuclear war. We are living on borrowed time, warmed by the fire of a dying star in an utterly indifferent universe.